Alright, so for the warm-up, you are foiling. So for x plus 2 times x minus 2, when you distribute and FOIL that, you go first, so you get x squared, outer minus 2x, inner plus 2x, and last 2 times negative 2, which is negative 4. So you get x squared minus 2x plus 2x minus 4, which simplifies to x squared minus 4, because a plus 2x and minus 2x cancel. We're going to do the same thing in the next example. So 4 times 4 is 16. X times x is x squared. Then you do outer, 4 times 5. So you have negative 20x. Inner is positive 20x. And last gives you 5 times 5, or negative 25. Once again, your middle terms cancel, leaving you with 16x squared minus 25. So today we're looking at factoring quadratic expressions. It's our second day of 5-3, and we are looking at using two different formulas. The first formula is difference of squares, and the second formula is a perfect square trinomial formula. So a difference of squares consists of a binomial that is multiplying two perfect square trinomials. It is going to look like a squared minus b squared, quantity a minus b, a plus b, or a squared minus b squared, and you write it as quantity a plus b, a minus b. The order that we write them does not matter. So when we're looking at these equations, we're looking for two perfect squares and a subtraction in the middle. The word difference means subtract. If they are being added together, then the formula does not apply. So the word difference means subtract. If they're being added, the formula does not apply. When factoring a difference of squares, you want to look for the following two items. Two terms, a minus between the two terms, and both terms must be perfect. So we can take the following expression and factor it using our formula. X squared is a perfect square. 16 is a perfect square. I have a subtraction sign between them. So this is going to factor as x minus 4, x plus 4, where it's the square root of the first and the square root of the second. So the square root of 16 is 4, therefore it is 4 and 4. Okay, x squared minus 49. So once again, x squared is a perfect square. 49 is a perfect square. Therefore, you have x minus 7, x plus 7. And before we turn over in our notes packets to that next page, I want to write down the perfect squares for you, just to make sure we know them. So our perfect squares are 0, 1, 4, 9, 16, 25, 81, 100, 121, 144, 169, 196. So again, that's up through 14. 15 is 225. And you probably won't need beyond that, but you do need these first 15 perfect squares. And the way it works is the square root of that number is the number that goes into our formula. Oh, I totally skipped 36 and 49. And 64. Just add those three at the end. 25, 36, 49, 64. I think I was saying them faster than I could write them. Yeah, I missed my 36, 49, 64. So when you look at a number in a problem like that, you would go over here and say, hey, it's a perfect square. I can do my formula. So if we look at the next example, you have 4x squared minus 1. So 4 is over there, 1 is over there. Therefore, the difference of squares formula applies. So we have the square root of 4, which is 2. And if you don't know a square root, you can always put it on your calculator. So you have 2x, 2x, 1 positive, 1 negative. And again, the square root of 1 on your calculator is 1. So you have plus 1, minus 1. So you're just plugging into the formula where this is a squared minus b squared. So in this case, it's the square root of a squared equals a, square root of b squared equals b, and you plug into a plus b, a minus b. So you can see exactly how we are filling in our formulas. Everybody kind of remember doing this? Okay, 36x squared minus 81. 36 is a perfect square. It's 6. 81 is a perfect square. It's 9. So your perfect squares are 36 and 81. We have 1 positive, 1 negative, and then you fill in your perfect squares. The second special formula we're going to look at is a perfect square trinomial. A perfect square trinomial is the product you obtain when you square a binomial. This one has 3 terms, a squared plus 2ab plus b squared, and they always factor as positives or negatives depending on the sign in the second part. So if the sign is positive, they factor as positives. If the sign is negative, they factor as negatives. And once again, it's the square root of the first and the square root of the last. The difference is that now the middle has to consist of the first term times the last term in their square roots times 2. So when factoring using a perfect square trinomial, we are, yes. Yeah, sorry guys. Are we okay now? No. Okay? So when factoring using perfect square trinomials, you are looking for the following three things. Three terms. The last term must be positive, and the first and last terms must be perfect squares. So for example, you have x squared plus 8x plus 16. So in this example, you look at the first term. X squared is considered a perfect square. Its square root is x. 16 is a perfect square. Its square root is 4. So your first term's a perfect square. Your last term's a perfect square. And the middle term needs to equal 2 times the first square root times the second square root. So 2 times x times 4 is 8x. So that matches the middle. If the middle term matches 2 times the square root of the first and the last, then this is considered a perfect square trinomial. We look at the sign after the first perfect square. It's positive. So that tells me that when I factor this, the middle term is positive. And then its factored form is the square root of the first term plus, because it's positive, the square root of the last term, which is 4. And then because it's a perfect square trinomial, that entire quantity is squared. Or you could write it as x plus 4, x plus 4. So it's really like saying you have x plus 4, x plus 4. It's a little different than the difference of squares, because in the difference of squares, you had a positive and a negative. For perfect square trinomials, both are either positive or both are negative. So, looking at this example here, we look at the first term, and I say, okay, that's a perfect square. 4 is a perfect square. X squared is a perfect square. So that's like 2x. We look at the last term, which is 9. 9 is a perfect square. We know it becomes 3. So then you have to determine, is the middle 2? A, B. So in this case, it's 2 times 2x times 3. So 2 times 2 is 4. 4 times 3 is 12. So we determine that the middle term is in fact a perfect square trinomial. So that means this factors as 2x plus 3 squared. Yep. Okay, so if yours has the minus, sorry about that, that would mean what changes then? Yeah, the sign in the middle. So this would be 2x, and instead of plus 3, it would be a minus 3. So if your handout has a minus, sorry about that, mine had a positive, they didn't match, but if it has a minus, the rules and everything still apply. The sign in the middle just changes. Okay, so 25x squared. 25 is a perfect square. X squared is a perfect square. So that's the same as the square root of 5x. Looking at 81, it's a perfect square. It's 9. So then you have to determine if the middle is 2 times 5x times 9. So 2 times 5 is 10. 10 times 9 is 90. So 2 times 5 times 9 is 90. The middle term is 90. Therefore, the rule applies. So we have 5x plus 9. 5x plus 9. Or 5x plus 9 squared. Okay, and then we have 10x squared, or 100x squared, which would become 10x. 81, which we just said, becomes 9. So then for your middle, you have to say 2 times 10x times 9. So 2 times 9 is 18. 18 times 10 is, in fact, 180x. So this is, in fact, a perfect square trinomial. And it becomes 10x plus 9 squared. Okay, last one. 64x squared minus 14x plus 1. 64x squared is a perfect square. It's 8x. 1 is a perfect square. It's 1. So then you multiply the first and the last times 2. And 2 times 8 is 16. Does 16 match my middle term? No. So if that middle term does not match, this is not factorable. Another way of saying that is writing out prime. And you can check it with your magic X also, which we're going to talk about tomorrow, well, Monday, I guess. So, your homework is that next two front and back in your packet. So it's the front and back in that packet. It's the next 2 pages. So due Monday is yesterday's front and back. So that is the magic X, the GCF, and then it's your difference of squares and your perfect squares. And that is all due at 10 a.m. And then I just want, yes. Yes. And then I want to make a generalized announcement that I, on Delta Math, posted an assignment. That assignment on Delta Math is optional. It is 20 questions. So if your grade is at a point where you are unhappy, then it is 20 questions. If you do all 20 questions, whether you get them right or wrong, you can earn a 20 out of 20. If you do all 20 questions and you get them all correct, then you can potentially earn a 30 out of 20. If you do 20 questions and you get 5 correct, then you could get a 22 out of 20. So, if you're happy with your grade and you're good, you don't have to do this. So if your grade is where you're at and you like it and you're good, don't touch the Delta Math assignment. If your grade isn't where you want it to be, do the Delta Math. The only way to make the Delta Math harm you would be to do like 5 of 20 questions and just quit. Okay? Does that make sense? I sent it on Teams. I put all the info out on Teams. It's already posted to Delta Math. Now, slight change. That is due at 8 a.m. on Monday. It's due earlier so that I can get your grades in for it, because grades are due at that end of the day, and I just want it to be done a little earlier. So it's due at 8 a.m. where your homework's due at 10, because I know a lot of you work on the Delta Maths, in that nitty-gritty time right before they're due. Some of you are working on it at 8:40 this morning. I was watching. So that one is due at 8 a.m.